Hello, maybe in English, right? So my name is Grzegorz, Ochmanski, and I'm from Amazon Web Services. And I welcome you from this beautiful Google Hall. I'm not sure if this was trolling. If this was trolling, it was an art, I have to say. A perfect troll. So really, no, we are really happy. I mean, all greetings from my colleagues from Google. Just to set a scene, the game production, right, itself, this process, I actually should have put those arrows all together, in all the random directions, because this is how it happens. But I would like to focus on this very, production subject. Of course, this is way much more complicated than I'm able to show. That's why I would like to focus on that area, which is like workstation, build pipelines, version control, build farm, supporting solutions. And this is like, I'm stressing out the supporting solutions because there are many, right? Cloud has more than 300 services, and this is some of them, right? So this is AWS for games ecosystem. And yeah, we focus on the build, run, and grow, right? And whatever you would need, probably we might have it. If you would like to bootstrap it, we probably also could do it. Having said this, why should you use cloud? I mean, how could you use cloud? Potentially imagine that you have a classic game, right? The classic fantasy, roguelike MMORPG with shooter elements, right? Like very simple to visualize and set up that game. So if it's like MMORPG game, you probably need some networking, right? You have a global distribution, you're everywhere, you would like to have the player base around the world. And you say, okay, I would like to use some of the networking, and you're just thinking where to put your server. So the cloud infrastructure is there for you, and you can use it. So yeah, feel free. We have more than 27 regions, 400, points of present locations. Up to you. You can use it starting day one. This is on why should you use it, or can you use it? Yes, you can. Should you use it? Probably, if this is it meets your requirements, then for sure. So now the virtual workstation. So how to start with the game production in the cloud, right? So you need to work on something before you have your developer workstation. So then you think about workstations and the pixel streaming. In a second about what is that, because that can be, you might have mixed feelings about the pixel streaming. So how to start? We have the virtual VMs in the cloud, meaning EC2 instances on AWS Cloud, with the GPU support, and that's all you need actually. I'm not in the position to tell you, yeah, you need this and that graphic card, you need to test it by yourself. What we are offering are, in fact, so G4 and G5 family of instances. And what is specific about them, they have the GPU connected. Those are not the RTXs, you might know, but those are the same architecture, but those are more these enterprise-grade cards. And this is NVIDIA Tesla T4 or NVIDIA A10G. And those have respectively 16 gigs of GDDR6 of the graphic RAM, or the 24 gigabytes when we speak about the A10G. The performance, you can check on NVIDIA how they perform in games, but they are okay, yeah, in terms of running your game in 2K, 4K, probably A10G is able to handle that. How you can run those workspaces, that's another thing. Because there are multiple offerings, right? Because when you just browse the cloud, you would go to AWS for games, and you see like, oh, we have this 300 services, like AI, ML, everything is there, right? How I can run this stuff? So I can narrow it down to, in fact, 3 services. One is the Nimble Studio for games, relatively new. So in the beginning, the Nimble Studio, what it does is it's actually starting you the virtual workstation. But you build your image yourself, right? And it's kind of semi-automated, so I'll go with the semi-automated, like Nimble Studio for games, relatively new. Workspaces, it's kind of like a Citrix stuff. How you can run those workstations, it's fully managed, yeah, essentially. And you are able to self-host the instances. If you would like to test, probably you would like to go with self-managed, self-hosted solution. So you just start EC2 instance, install some pixel streaming solution, like remote desktop stuff, and start with that. So those are those three core options. The semi-automated, meaning Nimble Studio for games, it will give you a very nice client to connect to this pixel streaming. In a second about that. But one discrete thing which we often overlook when we think about the game production in the cloud, or at least connecting to these things, is the security layer and the discrete connectivity, meaning you really probably should, if you're going to use that in production mode, you probably would like to have, although the protocol itself has the encryption and stuff, you probably would like to have some sort of VPN connection there ensured, because you're connecting over the network. Of course, you could connect directly with AWS, but yeah, when we are starting evaluating, you probably would like to start with connecting over internet and then going to a VPN solution, maybe, right? And now the pixel streaming, which might be misleading, because if you are in Unreal, by the way, a short quiz, do you know how many Unreal sessions were there today? I was counting. So there were no answers, nobody knows. So if you would be counting the agenda, there were 6 sessions about the Unreal, right? So if you know Unreal, you probably had and seen somewhere in the documentation the pixel streaming, right? WebRTC add-on for Unreal. So this is not exactly this one. So as a pixel streaming, it's kind of like new remote desktop protocol version, I would say, so that it has its own protocol. It's kind of like a desktop version, Netflix version of your desktop, which you can interact with. You can actually play games with it. So why I'm speaking about that, because if you ever worked in a studio and you had Citrix, for example, to operate remotely on the dev machine, you might have mixed feelings about like how it performs. But with this one, it has the compression, so it has H.264 compression. So you are able to see your screen, and it dynamically adjusts to your network bandwidth. So of course, like Netflix, you will have a lot of artifacts, but it will not break the connection. You will not have the lagging or scrubbling of your screen. It will be just a bit blurry for a second, right? Still not the best, but imagine we are talking about public network with latency. What is also good about those protocols, they can use TCP and UDP, right? But what is good, you can have the USB remotization, so you can connect your, your gamepad. I'm connecting my Xbox controller, and you can even play a game. You can have a stable 60 FPS with dual monitor display. Up to you, right? What are the differences between them? Those are having a bit different approach. I would say they have the different protocol, but they realize the same function. So NiceDCV is like one from Amazon Web Services, and you will see this under the hood of many services. If you were be using the upstreaming, if you would be using Workspaces or the Nimble Studio I mentioned before, under the client there is NiceDCV as a protocol, right? It has also SDK, so you can embed it in the web browser through the WebRTC. So almost like a pixel streaming from Unreal, right? Another one is Parsec, that's our partner, and this is mostly they were coming from the area. Okay, we are like, you can game in the cloud, right? So you can have game on remote computer. So this is their approach. And there's of course Teradici. Teradici, what is special about them, and why I'm mentioning them, they have the full 888-bit of RGB palette representation, meaning you can have really true color through the Teradici. Of course, they are copy-paste. They are you can fully customize them to your needs. So if you don't want to have the copy-paste, because if you have your cloud environment, in a second about that, you might not want your users to be copying files directly without any scanning, right? Unless you are like whatever, and you would like to spread something in your cloud environment. But yeah, it's up to you. So essentially the workstations, the pixel streaming is there. So another thing, as I counted 6 sessions about the Unreal, if you're working in Unreal environment, you probably will have some sort of perforce Helix core, meaning the SCM and the version control system implemented. What to do with it? Yeah, it works in the cloud. what not to do. I can tell that I've seen this configuration more than I should, probably, but there was one extreme example which I'm depicting here more or less. So there was like a USB drive connected to a server, and it was running the main depot of the studio. Yeah, don't do it. And if you would like to do it, do it smartly, right? Do the backups. So, as you know, if you're working with the perforce, when you're submitting, if you run p4 submit, it is compressing the artifacts is being submitted to a depot. So it will do the compression. So yeah, perforce is quite good with compressing things. So yeah, it will push some I/O on both the storage, and it will require some CPU as well. So you don't want to put it on random PC, right? You would like to have some performance out of it, especially when you scale, right? If you have just the basic free perforce with 5 users, right? We know that 5 users sometimes with perforce translates to like 20 or 30. Yeah, we are multitasking there. And up to 20 workspaces, it's free. But yeah, the more you use it, for example, in a clean build, you'd like to pull everything from your repo to do a clean build, that will put also the stress on I/O on the underlying storage. So if you have the USB drive and you have the HX depots there, so meaning your version files and the HX metadata, this is really like DB file. So this is a random pattern. You should be looking into the most performance you can get from it. Yeah, not a USB drive. So essentially, don't do it. Yeah, but if you do it, do backups. Yeah, please do the backups, because if you lose your version control, yeah, you don't have backup, you lost your work. Yeah, there is the thing called server the deployment package from Perforce, and it includes AWS as well. So you will have the manual for AWS. In a second about that. So do's, if you have already in your basement or under your desk the perforce, and what can you do? You can of course take site-to-site VPN. This is what I was talking about, the discrete connections. You can get the VPN connection and you can kick it to AWS by creating a forwarding or standby replica, right? You probably heard about the perforce and if you were working with it, and proxy servers. They are just caching. Forwarding replica can be acting as the failover to a perforce master server. So if you're backing it up, they actually call it the live backup, the replication. That's how you call it. But the one interesting thing about the forwarding and standby replicas is that if you installed some time ago, we know how it works, right? You installed perforce for this free one. Years ago, you're not updating it, and it just sits there, and it was on Windows, and you would like to now go with the server deployment package, and you would like to migrate it to Linux. And you're like, yeah, how I do it? And you look at the perforce guide, and it's like really scary. But you can do it through the forwarding replica as well. It's about case sensitivity in the path of your depot, because Linux is case sensitive. If you type downloads and downloads upper lowercase, it's difference for Linux, it's not a difference for Windows. But yeah, the forwarding replicas, they can be a backup, the live backup of your chess Fantasy RPG with the shooter elements, after you decide to build what. Another thing which SDP is treating about, and this is the perforce talking about, yeah, we have AWS, just deploy it on, this is the configuration. They deploy it on so-called elastic block storage, elastic block store, EBS. And those are really the block volumes, and they have quite, I would say, outdated information there, saying, oh, you will put it on low spinning drive, will get you the nice perforce configuration, but underlying storage will be, yeah, we can improve that. So what you can do is you can use the Open ZFS from FSX, from Amazon Web Services. Why ZFS is so cool? It's not only highly performing file system, but it also allows you to do snapshots. And as you might know, having a backups of your depots and the metadata, they need to be crash consistent. They need to be the best is when they are backup at the same time. So you probably would like to make a snapshot, synchronously for those two mount points in this case. If we speak Linux, two directories. If we speak Windows, you would like to kind of snapshot them at the same time. And the best thing is that snapshots from the OpenZFS don't take space because they are copy and write. Yeah, which is a bit of the lower storage level. Okay, but you might say, okay, I have the studio, I run with the perforce document, and I have like the perfect setup, and yeah, I'm like good. Yeah, I don't want you to messing around or advise me something that's good. So this is one of the deployments, like according, I'm not sure that this is visible. I'll try to kind of talk about it. The solution which is described in the perforce document. So what you see here, this is the EBS. It really says EBS. It's a bit blurry. Sorry for that. And they want to put on the block device the HX metadata and HX logs and the depot file, so your version system on EFS. Which is Elastic File System, and it might not be the best case. Of course, you have the replication, you would be safe. This is not critically bad, but here you would have the proxy server, right? Still, so why it's maybe not the best thing to do? First, you would have to remember, okay, the HX depots and the metadata, I would like to take the snapshot of this at the same time, meaning, okay, I need to have it crash consistent backups on EC2. And additionally, this is the EFS, and it was created for more like the home directories of the users on Linux, and this is the NFS 4.1, 4.2, meaning it won't work on Windows as a client. And you would like to just mount it, but there is the thing that it scales not only in size but also with the performance. It scales with the grow, right? So the performance goes with the size. And if you're copying large, you have, let's say, 20 terabytes of your depots, and if you'd like to copy to this setup, it would take ages, right, until it scales and gives you the sweet IOPS and the sweet performance. So this is maybe something you would think to improve. And the last thing, of course, when you're considering the perforce implementation in the cloud, I think this is not only for AWS, you need to think about the costs, right? And what is the direction of the data you're going to send? Because uploading things to the cloud is free, but downloading from the cloud is, there is a charge for that. And this is the entire thing, how you set up your perforce, other types of perforce servers, so you can optimize not only for performance but also for the cost. And putting a proxy might be an expensive solution, especially when you're doing, the clean builds. You go with, you don't have any cache. If this is not cached by the proxy server, it will pull everything what you are before syncing from the master server. And in this case, it might get pricey because you're downloading things from the cloud. So there are things to improve, right? So what to do with it? So as I said about the replication for the backup, you can take that approach, but develop it a bit further. So you're replicating, so you have a standby, right? If something goes wrong, you have your sweet failover, and then you have another replica because you're having the MMORPG, right? You have distributed team, you have guys sitting in US, Japan, and Fiji Islands, and you would like to have it distributed globally. And that's where your MMORPG, or how your MMORPG will be built. So you take the cloud and you can set up in every region. You have the forwarding replica, and that's because you have a small edge server there with your team in some remote office in far away Western Europe will be sitting, and that edge server, instead of going to a master server in the United States, it will be going to a local replica, right? And they are of course replicating everything. So what else you can do? Of course, you can do the best of what you can do. You can do the HX metadata, logs, and depots. You can keep on the separate zvols on the OpenZFS, which gives you the snapshotting capability I was talking about. Of course, there is the local forwarding and standby replica. You can fail over in between them if you're doing something hacky with the current master commit server. And of course, you have the remote replica in case something happens in your home region. So that presentation really has the logical flow, I hope. So if you have your SCM or the version control in the cloud already, so you can start building, right? You're using for your MRPG, you have your virtual workstation, it works, you're happy with it. You have your perforce, but you have to build somewhere. And this thing where somewhere is AWS Cloud, probably, if you're using AWS for your perforce hosting. And this is one thing to think about. So building, I know the swarm, that's why I put the asterisk there, for light mass baking. I put it there because it has the common characteristics in the cloud with the Incredibuild, fast build, TeamCity, JFrog, Jenkins, or whatever you're going to use. They have very similar. You can have very similar approach when it comes to the cloud deployment. And why to use AWS Cloud for this, or cloud at all, is because they have the spare capacity that you're going to borrow for the time of building. And especially in the swarm with Lumen, you need to build those light maps somewhere. And you don't want to block your build farm, so you don't want to build like 20 farms of servers unless you have too much money, which I really hope for you to have. But sometimes you just want to borrow for a second or two the spare capacity because you're starting the new project, right? So one thing what is very similar in those approaches is that they don't scale dynamically, meaning you can't have a single metric which will tell you, okay, auto-scale me this to 1,000 nodes immediately because there's metric, there's like high CPU. Additionally, they are very traditional in approach, meaning that they will run on virtual machine, in this case in the cloud. But they have the long startup time, right? Swarm is only available on Windows, and this will take a really long time for Swarm agents to be ready to serve in the cluster. The same goes for Incredibuild, the same goes for Fast Build or Jenkins or TeamCity, but they are doing a clever way. If you use they have all some sorts of the cloud extensions. The one from Jenkins I like especially because it has this very noise comment there. But they use the fleet where you have to bake an image, right? So you have a VM. They are very step in scaling. But you have to bake this image, the AMI, which is Amazon Machine Image. This is a template, so you have to pack your, the Jenkins agent in this case, or TeamCity agent, JFrog agent, CloudBee agent, and so on. You have to build it into the image, and after that, of course, you need to have the P4 client as well, which in the coordinator, which will pull this code from the repository and allow you to build. And going with the pipeline, so this is the scaling, and I wanted to say something really clever about the pipelines, but I have to say that this really depends if you're a mobile developer, if you're developing for Unreal, if you're using Unity, that will all differ, right? Because with Unity you have Plastic SCM probably, or you have Unity Cloud builds. There are all the different sorts of offering which help you to build in the cloud. This is a very Unreal kind of scenario, but I picked it up and draw it because there's a perforce, right? And my Fantasy Chess MMORPG with shooter elements should be using the perforce in this case. And it was 6 times mentioned in this conference, so I think that pretty much a lot of people will be using that. At least for Unreal. So you're building, right? And this is Jenkins. Yeah, we like Jenkins. And you can build, of course, you can cross-compile. And for that, we have Mac instances as well, if you would like to have the Mac code signing. That's why I picked this example, because you have the spot capacity. This is extra capacity with the lowered price from AWS, and you will have it used as the build nodes. And of course, this step scaling, how Jenkins handles that goes for Incredibuild as well. They create you some pool of instances, that can be, like hundreds of instances. And what they do in case when they know what job is coming and whether this is, some incremental build, full build, or how many of those resources they allocated initially, right? They allocated 100, how much of them they would like to use, and they can, so these pipeline tools are here, or CI/CD tools are very important for the scaling, because they know what job is coming, and they can enable or activate as many as they need for a job, right? We have some quick incremental build, we won't need, 100 servers, we won't need 2,000 cores to do this compilation, we will just use, 10. Right? So they will activate 10, build on them, get your output to a build sharing solution, hopefully, in a second about that. And yeah, they are happy, and you paid just for 5 seconds doing your build. So probably if you are a mobile developer, and you will see a bit of different pipeline, and that's why I said I would like to say something clever, but it differs. You can do your pipeline, your CI/CD with the JFrog, CloudBees, Jenkins, or even the Bash script. You can have the Bash script. There's nothing wrong with it. You can still do these things, the scaling. You will, before the build happens, you can still hit there and hit the amount of instances you would like to have, and you will have it. Right? We have the full SDK and CLI for that. You can have it in Bash script. Why I'm stressing out this build sharing solution, because this is something often overlooked. I'm not sure if you encounter this situation, but this is important for you if you are running for a QA, or you would like to have your testers to have the fresh build, or even if you have a daily stand-up in the morning and you would like to know what is the fresh build currently, and you would like to share it everywhere, and you have distributed team all over the world, and you're lagging 5 builds behind because your SFTP server is not performing too well. So this is where really this build sharing solution comes in place. So that would be about the pipelines, and I would speak about the continuous delivery. So the delivery don't mean the deployment, so I'm not going to say about like how you should deploy to Steam or to the PlayStation account. So this is one of the supporting solutions I mentioned in the very beginning, how not to do things. So usually I hear about the SFTP servers sending and seeding those builds, and so Jenkins, let's say in the post-build step, it just copies the file to an SFTP server, and this is how you get it. But imagine that you have your classic chess MMORPG with a shooter elements, and you have the developers from Japan, and they are just pulling this from the SFTP server, and it takes ages, right? 100 kilobytes per second, downloading the PlayStation 5 build. Yeah, that's a challenge. So what not to do in case, even if you would be brave enough to have the free SFTP servers in AWS, you would think, yeah, that's maybe not the best idea. I'm duplicating resources, right? I'm duplicating in all 3 regions. Additionally, this replication here is not synchronous, meaning if you throw everything to your S3 bucket, it won't be automatically available in all 3 regions. You will have to wait a bit for it. It's not a critical subject if you're doing a nightly build or a couple of builds, but if you're building over the day and you're working with your partner and you would like to really have it everybody in sync, or you have your the team working really remotely for some art, and you would like to give them the freshly compiled version with all the tools of Unreal Engine, you would probably like to change it somewhere there. And there is the build sharing solution and what to do with it. That might look complicated, but it really is fully serverless. I missed the arrow there. No worries. You'll share it with me later. So what would you like to do? You have the CloudFront distribution, meaning there's like the AWS has the CDN, Content Delivery Network, and this is 400 locations, or plus 400 locations I was talking about. So you have one in most major cities around the globe. So this is where your somebody on the other side will be connecting to and grabbing those files. You have S3 bucket, which is just object storage. You have some bunch of Lambda and Hacky scripts you might have, and of course the vault for the secrets like RSA keys, etc. And of course the API gateway and an arrow I forgot to animate there. First thing, single source of truth. There are no multiple buckets. There's no asynchronous replication. So whatever you put in here, it will be through this available to these folks, right? So my MMORPG can be pulled immediately, so the build is fresh. And this is really high-performing CDN. So you will be able to saturate your bandwidth. And it happened to me that we had to throttle a bit of the network on the other side because we were killing internet when the automatic build was downloading from the CDN. And this is like single source true, right? So following, there is a very specific feature of the CDN, which is the signed URL. What is signed URL? This is really just the signed URL with the RSA tough acronym, key of your selection. So you basically generate your RSA key, you upload it, and it will sign this URL with the key. And when you are going to access this, it will ask for the public key to decrypt it and verify it if you're eligible to access it. And if you're not, you won't get it allowed to download. And this can be very generated in flight, and that's why we have this. This is the Amazon API gateway, and this is just really a REST API. And behind this, there is the entire logic, meaning this is just like a reverse proxy activating those functions, and they just generate you pre-signed URL. So this one redirects you from this. So HTTP 302 and permanently or temporarily moved. Redirect you to this new signed URL, and that developer or the other remote team will be redirected to a CDN. So instead of hitting, an additional region, because this is a regional resource, they will be getting it from the global distribution somewhere from, the closest location of their choice. And there is, of course, the secrets manager about the vault to store the RSA keys, in that case, for those pre-signed URLs. And this is really just serverless. There is no server running, so it's quite cheap to maintain and portable to distribute. And there is the last thing really I wanted to discuss. I really just fast forward through all those slides, but the automatic crash dump collection. So as I've checked maybe 20, when I was doing a research for this presentation, I was browsing the studios, and I was checking how they are handling the crash dumps, right? You have new release, you're releasing the self-publishing, you have your client, and it's crashing. And you don't want that to be happening, or your game is crashing, and you would like to know something about it, why it's happening, especially in this very critical moment when you're just launching it. And there is this automated solution, but what I've seen from my research is like, if you have the crash, you collect this and that log, and you send us the link from any public available storage. You send us a link, and we will look into it. I'm not sure if you would like to have that. Probably you would like to automate it in some way. And there is this little handy solution. Again, this is almost serverless, except this part, and this is really for some processing of the crash dumps. So what it helps you to do, you just need to, of course, ask the user, because you will be uploading something from their computer, right, somewhere to the cloud. But what it has, the property of the S3, which is object storage in this case, it has so-called pre-signed URL. I know there's like confusion with signed, pre-signed, but what is pre-signed, it's kind of like a one-way ticket, right? This is like one-time link to upload an element to an S3 bucket. And what you can do with it, you can, of course, trigger some notification, and you can trigger some sort of analytics. So what happens behind the scenes when the crash happens, you prompt the player to say, okay, would you like to set automatic crash dump? And he said, of course, no. But if he presses yes, then what happens under the scene? There's API gateway, of course, which client is hitting. Then get this pre-signed URL. This pre-signed URL then is coming from the S3 bucket. The client is uploading the crash dump here, and you have those crash dump collections from most of major engines like Unity, Unreal, Godot, and all sorts of things allow you to collect this crash dump. Portion of Windows log as well, probably. And what you do, you of course trigger the notification, and this is a queue of the jobs, and there are the instances, meaning some compute elements, which will be processing, unpacking probably those crash dumps and crunching through them. So you are just chopping the pieces, unneeded pieces, or you can have even the machine learning model which will be analyzing those crash dumps for you. This is how you can basically implement more advanced analytics of those crash dumps. And I think this is the last one, really. So I open up to questions if you might have any. And this is, of course, my contact points if you'd like to talk about it. So do you have any questions? No, it's 6 p.m. 7 p.m. almost. I just want to go. Yeah, so thank you very much for attention. And if you'd like to keep in touch with me, there's my Discord, there's my email. You can find me on LinkedIn. And yeah, I'm free, meaning, for you, I'm free. So always ping me and I will be able to help if I can. So thank you very much.